integer array nums and an integer k, return the kth largest element in the array. The kth largest element in the array. Note that it is kth largest element in the sorted order, not the kth distinct element. Can you solve it without sorting? Okay, so first of all, this nums is not going to be sorted then. K, I'm assuming the range can be from 1 to some great number. Like, how big can nums be? Can it be empty? Are the duplicates allowed? I'm assuming you can choose any of the duplicates if they are. Can you solve it without sorting? So using that min heap strategy from before, where you keep the size of the min heap to be size k, doesn't work anymore because, well, if you have the kth largest, right? If you have the k, like the max heap will only store the largest element, and all of it won't store the kth largest. And a min heap, it would store the kth smallest, but that's different from the kth largest. Maybe we can do like calculation, like complement each other, like the kth smallest, like the total elements in the heap minus the kth smallest gives you the kth largest. You know what I mean? Like something like that maybe. Confirming the constraints down here. K is 1. Nums line thing can be 10 to the power of 5, okay? And these are the values of I. I'm assuming they're they're integers. Well, I mean, even if you sort, like if I sorted the array, well, that'd be easy. Then I could just like do return the index, right? Yeah, but I guess if you didn't know this was a heap question, that would be like a good train of thought. So that's n log of n, and I guess we're looking for a more optimal solution. N. You put the. Do we need 2? Like a max heap and a min heap? Well, we know the total number of elements in the array. We know k, right? So with the total elements k, we have, let's take this example here, 3, 2, 1, 5, 6, 4, okay? The largest element is 6, the second largest is 5, so 5 should be the output, okay? The total number of elements is 6. We know k is equal to 2. 6 minus 2 is 4. Is that the kth smallest element as well? Sorry, the fourth smallest element as well? So we have 1 here. We have 2. We have 3. We have 4. 1, 2, 3, 4. No, it's the fifth smallest. So 6 minus 2 minus 1 or plus 1. Let's try that. So when I say 6, I mean like the length of nums minus k plus 1. Okay, so let's try it for this one. We want the fourth smallest element, so that I see 6, 5, 5, so duplicates 5, 5, and 4, yeah. And then, so now there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 minus 4 plus 1 is 6. So the sixth smallest element. So we have 1, 2, 3, 4, 5, 6. I think that works. Okay, well, hold on. So now we have the sixth smallest element. Okay. We have the sixth smallest element. How do I fit this into the bigger picture? What do we want at the end of the day? We want to return that the sixth smallest or whatever. How does that work for the other question? We had a min heap, and in a min heap we constrain that min heap to a size of k, yeah, and then can we constrain the size to be of length 4? Okay, and just pop. Just continue popping until we get that. I think that would work actually. Like we have this array of 9. You want to get it down to a length like just 4. Alright, so we continue popping. We're gonna pop 1, 2, 3, 4, 5, and then 6. We don't want to pop on the 6th one. So for length of nums minus k is the number of times we want to pop it, and then we have a min heap. And in reality, that min heap, the one at the element at the root, is actually the kth largest because of the calculation that we've done. I think that'll work. Let's try it. So we have heap q, heapify, and we want to heapify nums, I think. Right? I think so. And then while a length of nums. Yeah, this doesn't return anything, it just turns this num into a heap. But while this is greater than length of nums minus k, is that right? That doesn't feel right. So this is 9. Wait, so I said this, and when this is equal to 0, so does that mean after we solve the inequality, something like this? You saw what I did there? Like, that was a fun math. I love doing that, where like you just move the k over to the like plus k here, and then plus k over there, like on the other side of the inequality. That's fun. Okay. that work? 4. Well, let's try it. I don't know. Heap Q. Heap up. Nums. And then we return the element at 0. What if k is always greater than 1, so that's good to know. It can be equal to 1, but this is 2. This is going to be 1. When this is 1, it won't pop anything. So we're always guaranteed that we're going to have something. This should work. Let's try it out. So heap q, heap of my nums, this. While length of nums is greater than k. Okay, so this length is 6. I'm just gonna, it's gonna help me visualize like a debugger. And k we know is equal to 2. We pop the smallest one. We pop at 1. Okay? Now it's 5. We pop out 2. Now it's 4. We pop out 3. Now it's 3. We pop out 4. Sorry. It should be length 2. We pop out 4. Now it should only be 5 and 6. The minimum one is 5. And that's actually the k to the largest, which is the second largest. This example as well. We have 9. We pop out this. Oh, we're at 8. We pop out that. We're at 7, 6, 5, 4. Okay, and now that's matching. So now we're gone with 1, 2, 2, 3, 3, and now we're left with 4. And that's correct. It should be 4. Beautiful. Let's see. Rip. Huh? Yo, that's satisfying. Oh, nice, man. Nice. Okay. I like that. That was good.